Hello, I'm here today to talk about the concept of using risk tolerance to identify optimal cross passes. So before I dive into things, I'd like to tell you a bit about myself so you can get to know me a bit more. My name is Caitlan, and as you can probably tell from the image on the screen, I am Canadian. That's a photo of me playing hockey, which is, my main sport, but I do play soccer, or as most of you probably call it, football. And that was, very helpful in helping me, navigate this project and just having that baseline understanding of the game. Aside from that, I'm an undergraduate student at the University of Waterloo, where I study management engineering with options in statistics and computing. And when I'm not in class, I'm working as a data science intern at a fintech company. So luckily for this project, I was really able to use many concepts I learned in school, such as basic optimization, machine learning, UI design, probability theory, and decision-making under uncertainty. So it was great to, just wrap up all these concepts into one single project. So the reason that I'm here presenting to you all today is because I built this project for the Women in Sports Data Hackathon this year, where the prompt was to build an application or recommendation geared towards front office or coaching staff using the StatsBomb 360 data. I had about a month and a half for developing this, where I was then selected to present as a finalist in Brooklyn, New York, at the symposium, where I did end up placing first for my project. So, I have the Women in Sports Data Symposium and Hackathon to thank for, being the inception of this project. But of course, I'd like to thank StatsBomb for, sponsoring the data for the project, as well as inviting me to present to you all today. I really wish I could have been there in person, but I hope you'll still enjoy this video instead. So with that, I like to dub this project as the cross probability tool, but the high-level concepts and aspect of risk used in this hackathon project can extend, to other areas of the game, other sports, not just crossing and soccer. So this tool was initially built using the men's 2020 Euro data, but I have since excitingly integrated the newly released women's 2022 Euro data, which it's just great that this data is publicly available now, as well as it's just so exciting the initiatives that StatsBomb is taking in advancing the women's game with analytics. So with that, let's talk about, my project. I, knew I wanted to look at passing as well as, some sort of decision-making aspect in there. And from there, I just chose to, narrow my scope to look at just cross passes because I thought I didn't see too much research done on cross passes, so I thought it'd be a bit different. So when I really, dove into working on this project, I first started by doing a bit of research at crossing, done more at the professional level. And one thing that stood out to me was this comment in an article, essentially stating that crosses are ineffective and often lead to turnovers, and teams should move away from these kind of passes. So, that kind of caught me off guard in hearing, that side of the opinion. But then, on the other hand, my kind of argument is that teams are starting to play, a much wider game. Players are inevitably going to end up with the ball deep in the corner throughout the game still. And crosses are a great way to place the ball in front of the net quickly and get your opponent turning. So maybe instead of avoiding these passes, teams should instead focus in on dialing in their cross passes to lead to more dangerous scoring opportunities. So now if we look at the StatsBomb data, we see that for the men's game, crosses have roughly a 33% success rate, but of those completed crosses, 44% led to shots and roughly 10% of those shots led to goals. Now switching over to looking at the women's game, we see roughly the same success rate with way less shots, which is pretty interesting, yet still the same percentage of goals. And just for context in all this, about 9% of all shots on the pitch lead to goals. So this just goes to show that these cross passes are just as dangerous of a scoring play as any other shot on the field. And this is just looking at immediate shots. It doesn't consider shots made an action or two after the pass is made. So kind of the idea here is that if teams improve on their cross completion rate, then they will generate more goals as a result. So jumping ahead to my final solution, I knew I would need a probability of success for a cross. But on top of that, I was thinking as I was building it, It's one thing to have, this probability that a cross is completed, but what does a team gain from making this cross or making a cross to a certain area? And that's where I landed on the idea of using XG as a reward metric. And I chose XG as the measure because these types of passes place the ball near the net. So it seems like an appropriate metric to use. And then looking at this plot of kind of what my final output looks like, red indicates the optimal zone as predicted by the model. Blue is where the ball was actually placed. And in a later slide, you may see an example where the zone may be purple, and that just means that the prediction and the actual are the same. I would also like to point out that you may notice that some zones have a probability of 0. That's because the zone has no support in it or, no teammates in it. I understand that this may be a bit naive to just disregard these zones, as, players can run onto the ball in these empty zones. But, for simplicity in modeling and sake of time, I chose to disregard these zones. So let's get into how I implemented all this. I first started by making the assumption that crosses are made to space rather than to a direct recipient. And this is, because, with my experience and knowledge of crosses, it's that the person making the pass places the cross roughly to who/where they want it to go. But then it's your teammates' responsibility to ensure that they connect with that pass. This then led me to partitioning the field as such, and when looking at the historical transition probabilities for this particular partitioning, we see that most crosses are made from the outer flanks of the field to the middle section of the box. Now, this intuitively makes sense since we see that there's the highest chance of scoring as the closer you get to the net. But given that these crosses are often intercepted and incomplete, it made me think that, maybe there is a more productive location to be placing the ball instead of just placing it right in front of the net each time, while still, generating a good enough scoring opportunity. So that's kind of, motivation from here on out. So from there, if we look at processing the data, I generated the freeze frames for all players on the field. I then encode those player locations with the zones I just defined. And then I extract a few more features such as pressure on the player making the cross. And by pressure, I mean the number of players on that person making the cross. And I define that pressure radius as 3 yards. And that was pulled from a StatsBomb article. And then, I calculate the number of opponents and teammates in each possible end zone. And of course, we're given information on the outcome and the height of the cross. With that said, though, I do want to point out this plot. It shows that the majority of crosses are made high in the air, far more often than ground passes are, in which case I then simplified the modeling to assume crosses are made only in the air, as that's typically what we see. And this also ensures that we don't need to model the probability of being intercepted in any zone between the cross origin and the end location. Now, for modeling all this, I used a classification model to then be used to predict the probability of a successful cross using the features I just discussed. And I chose logistic regression for my model, given it's a model I'm more familiar with. So, I was then able to effectively parameter tune it and apply cross-validation to dial in the final model. Then for modeling XG, on the other hand, this came along a bit later in the hackathon build period. So for the sake of time and simplicity, I resorted to using just conditional probability to generate generalized XG values for each zone based on the number of opponents in that zone. And that probability just looks like this. It's the probability of a goal given the number of opponents in that zone. And I calculate that for each zone in each scenario independently. And this was sufficient enough for the proof of concept. So obviously there's some limitations to all this modeling, as you can probably imagine. One being the amount of data to train these models. So crosses are already a rather infrequent event. And on top of that, only being able to train on one tournament's worth of data is not really sufficient enough for having a high-performing model. So that's one limitation with this modeling. Another is just the models in general. So, perhaps there's opportunity to look at a model that better fits the crossing data, as well as, building a robust XG model using machine learning. That would also be ideal. Lastly, this modeling assumes that the pass is made to space, which may not always be the case, or which may not always be, ideal in certain scenarios. In which case, modeling the cross location to be a discrete player, could be a potential future extension of this modeling. So now I have this probability of success and I have a reward metric. I wanted a way to kind of tie these up into one single recommendation. So wrapping this all up led me to, thinking about situational analysis and how we use analytics to aid in finding the ground truth. But that truth might look different from person to person, and sometimes there's certain scenarios where the ground truth looks different for different teams, different times in the games. So, I was then thinking of all the coaches I've had in the past and knowing that no two people had the same coaching style. And this is what kind of sparked me to add in this element of risk aversion. And, if we think about it, some coaches, they're more conservative and they value maintained possession and the scoring chances will eventually come. Versus some coaches that like to play for those high reward opportunities, no matter the risk attached to it. And these are really the two extremes in this case. Additionally, risk attitude changes throughout the game. For example, if you're up a goal or two and it's late in the game, you're not going to want to take those high risk chances. Versus if you're late in the game and you're down a goal, you're going to have a greater taste for risk and you'll, play for those high scoring chance opportunities. So with this, this is where, the risk tolerance value allowed me to then wrap this all up into a single recommendation by leveraging simple optimization. And that optimization model just looks like this. It is the probability of a successful cross plus the risk tolerance multiplied onto the XG. I applied the risk weight and added the additional penalty factor of 0.2 specifically to the XG value because, as you can probably assume, the riskiest crosses often do reap the greatest rewards. And these rewards are often quite extreme and being rather high or low. So I needed a way to penalize these extreme values as to not dominate the optimization. So I essentially loop over each possible resultant section. I calculate the probability of a successful cross, the XG, and then from there I select the maximum. So here's the UI. It's fairly simple. I built it using Streamlit in Python. Users are able to select a tournament and then the match they'd like to focus in on, as well as drill down to a certain team. Then the crosses are labeled by the player that made the cross and the timestamp. Right above the plot, you can see if the cross was actually successful in the game or not, and then you can see the highlighted zones. And in this case, we have purple, which means the predicted and the actual are the same. So I envision this tool to be used for coaching staff to kind of identify where they should be placing their crosses based on their risk attitude, to help them learn of other areas that are ideal for them to place the ball, but to also aid in evaluating player decision making. So if you see a player is placing the ball in a section different from what the model is suggesting, or if a player is, consistently placing the ball in a riskier zone, then, you can kind of, the coach can then kind of flag it and take that into consideration. So here's an example of a risk-averse user. The cross was made to the middle of the box, but the model is suggesting that the player play the ball to this close zone. And then on the other hand, here is the example if a coach is risk-seeking, then the model suggests that it be placed in the middle of the box, which is indeed, in fact, where the ball was placed. So this is essentially how the UI works. It's pretty simple to navigate and work through and flip through all various crosses. So now I'll touch on some potential next steps I have in mind, given that this, is, still has room for improvement. First is being the possibility of looking into passes made to direct recipients rather than to space. Maybe a team has a player that's good at heading the ball and they want to know where they should be placing that player in different scenarios, or what a certain player's predicted probability of connecting with the ball is. With that, we would then probably need to model player movement, given that, the time of the ball in the air is not negligible. There's time for the players to move significantly. So that would need to be modeled. This point is kind of why I stuck to zones and passes made to space rather than to a direct recipient, because it lessens that effect of player movement and doesn't need to be considered as much. Lastly, the possibility of using different reward metrics. If we take the example of, a cross made to the top of the box, maybe coaches don't want their teams firing shots off from that far out, in which case expected threat may be a better measure of success. And, then the model could consider a weighted sum of these different metrics based on what the coach values more in their gameplay. And that's everything I have for you today. I want to thank you all for listening, as well as just thank you again for the opportunity. I really do appreciate it. Feel free to connect with me on LinkedIn or shoot me an email about any of this. And thank you again.